Why would you give it a shot?
Well, I think first, I don't want anybody to take out a piece of my brain.
Fellow Homo sapiens, welcome to Epilepsy Sparks Insights. Lots of people with an epilepsy might be nervous about getting gene therapy, but in today's episode, I ask our fabulous guest in part 2 of 2, epileptologist José Serratosa, if he would get gene therapy. José tells us about the use of viral vectors for treating genetic epilepsies, where we are in preclinical development, what is next, and what is also holding us back. And if you have listened to our other episodes, you can probably guess what this is. Please don't forget to like, comment and subscribe to the channel if you haven't already, so that we can educate regarding the epilepsies to more people all around the world.
I am a neurologist, an epileptologist, with a special interest in genetics, but the problem with viral vectors is the cost of the production. Also, because we need a large quantity of vector and we need a good quality with many quality controls. So the production of viral vectors is quite expensive, and of course, the clinical trials are always expensive. To finish the point, if there is only one injection in a lifetime, you can prevent immune reactions, hopefully. If you inject several times, that could be a bigger problem, because then there could be a reaction to the second, third.
So where are we in terms of the stage of the research into the use of viral vectors? We spoke about using rodents. What's the next stage, and when may it reach humans?
Well, the next stage after showing that something works in animal models is looking at the toxicology, finding the right dose, looking at the distribution. It's not very exciting, but it's something that has to be done. And after that, you may be allowed, if everything works out well, to do clinical trials. So I think we are in between the last stages of preclinical development, in some cases doing the toxicology, distribution, etc. tests, and the clinical trials. So I think in the next year we'll see some clinical trials.
Well, if I was pre-resection, I would put myself forward. I'd just be like, mate, go for it.
I would.
You would as well, would you?
Yeah.
That's important to hear, actually. Really powerful. You, the clinician, the scientist, you would give it a shot. Why would you give it a shot?
Well, I think first, I don't want anybody to take out a piece of my brain. I think neurosurgery is, it's of course an aggressive procedure.
Especially resection.
With the exception of, the minimal invasive procedures.
Laser ablation and...
Yeah. For many resections, you need to open the skull with a big, quite large opening. So that makes one point. And also, I think you may go to the problem that each specific patient has. So you can maybe look at the deficit that is present in a patient. For example, if you need more potassium channel activity, go with potassium channels. If you need receptor activity, etc. So you can probably look, and also because it would be an outpatient procedure with just one simple injection.
You're saying, though, that each individual vector implantation injection would be tailored to each individual person. It's not like one size fits all, like here's a jab, a vaccine for something. It would be tailored for each individual person?
We don't really know, but
okay.
It may be in the future that for example, I am just guessing, for a focal cortical dysplasia, you need this type of gene and channel, and for maybe a tumor, a benign tumor, you need another type of channel, maybe.
Not knowing is annoying, but also it's quite exciting and inspiring, I think, for research. It's like, God, we need to do this. We need the money from funding bodies to be able to literally do it.
Right.
Well, you were making me think of this. It was this Australian study about they calculated the cost of to society on average of a person with an epilepsy over a lifetime. I can't remember the amount, but it was something crazy. Like it was high. It was in the millions, I think, for each individual. And then, so thinking about that, when you said, okay, you could go in, have a jab, leave after half an hour, and the problem could be solved. The amount of just the benefit to wider society of that would just be wild. Amazingly wild, though.
Although it may cost also 1 or 2 million, because these treatments are now, at least now, very expensive.
But do you think perhaps the cost could come down a bit like genome sequencing? It used to be extraordinarily expensive. Now you can get it done for, well, depending where you go, but you can get it done for like €500 or something.
Yeah, I think it will get less expensive. I think in many years.
Fair.
We are working in the field of progressive myoclonic epilepsy, Lafora disease. This is a deadly disease for 95% of the patients. And we are trying to replace the abnormal gene in the patients. But now we are almost done with what we call proof of principle, showing that it works in mice. So it does work in mice. The Lafora bodies, which is an abnormal deposit in the neurons and other cells in the brain, are less than in non-treated animals. And the features, the clinical features, are also less in the treated animals. So we are trying to, go to the next preclinical studies so we can go to clinical trials maybe in a few years. It's a long process and it costs, that's the problem, millions of dollars, euros, whatever.
Thank you to Jose for his insight into the research into the use of viral vectors to treat the epilepsies. Now, we shall get there, but just never soon enough. Check out more about Jose and his work on the website toryrobinson.com, where you can also access the podcast, the video, and our transcript of this episode. And if you haven't already, do not forget to like, comment, and subscribe to the channel. Share this episode with your friends, colleagues, family members, whoever it might be, and see you next week.